Assalamualaikum and hi everyone. We are from Group 7 and we are assigned to solve and explain the answers in tutorial 4 question number 3. The question is, use Gauss theorem to evaluate double integral f dot n ds for the given f and sigma. Note that if they ask to evaluate double integral f dot n ds, which means we need to use triple integral divergent f dv. So for the first question, they have given f x y z equal to x minus zi plus y minus xj plus z minus yk. And the sigma is the surface of the cylinder x squared plus y squared equal to 4 from z equal to 0 to z equal to 1. First, we need to sketch the cylinder. I already sketched the cylinder. This is the cylinder with radius 2 and z from 0 to 1. For this question, we will use cylindrical coordinates because it is referred to the formula we need to use, which is triple integral divergence f dv. First, we need the limit for z, r and theta. From this, we know that the limit for z from 0 to 1. And then for r and theta, we know that this is the closed surface cylinder. So we look the xy plane. As we look at the xy plane, you can see that the theta is moving from 0 to 2 pi anti-clockwise and r is from 0 to 2. Now we find the divergent f and we get the answer is 3. And then we can find the double integral f dot n ds with the formula triple integral divergent f dv. dv will be dz r dr d theta, and we can substitute all the limit here. Z from 0 to 1, r from 0 to 2, theta from 0 to 2 pi. And these three we get from the divergent f. And now you can integrate one by one. First, integrate with dz and we get r dr 0 to 2, d theta 0 to 2 pi 3. And then we integrate with dr and then we get 2 d theta 0 to 2 pi 3. And lastly, we integrate with d theta and we get the final answer is 12 pi. Question 3 to Roman. They have given f xyz equal to x cubed I plus x squared y j plus xyk. The sigma is the surface of the region bounded by the parabolic cylinder z equal to 4 minus x squared and the planes y plus z equal to 5, z equal to 0 and y equal to 0. Same as question 1. First, we need to sketch the parabolic cylinder. I already sketched the parabolic cylinder here. As you can see, this is the parabolic cylinder with z equal to 4 minus x squared, and this one is the plane for y plus z equal to 5, and this one is the plane z equal to 0, and this one is the plane y equal to 0. So for this question, we need to use the Cartesian coordinates, and from this parabolic cylinder, we can get the limit for y, z, and x.
Question dv, we will use dy, dz, and dx. So limit for y, we get 0 to 5 minus z, which is 0 to the plane y plus z equal to 5. So for limit z is 0 to 4 minus x squared. So 0 until to the parabolic cylinder equation z equal to 4 minus x squared. So for x, we put 0 equal to z equal to 0. So we get the x limit is plus minus 2. So for the limit x, we get negative 2 until 2. Okay, after that, we integrate for x squared in terms of y. So for x squared will be a constant, and then we integrate, we will get y, and the limit is 0 until 5 minus z. So we put the limit into y, and then we get 4x squared in bracket 5 minus z bracket. So we simplify the equation, the function, we will get 20x squared minus 4x squared z. So we integrate in terms of dz. So we get 20x squared in bracket 4 minus x squared bracket minus 2x squared in bracket 4 minus x squared bracket squared. So when we simplify, we will get negative 2x to the power of 6 minus 4x to the power of 4 plus 48x squared. So we integrate, and then we get like this: negative 2x to the power of 7 over 7 minus 4x to the power of 5 over 5 plus 48x to the power of 3 over 3. So we put the limit into x, and then we get the answer 4608 over 35. Okay, for question 3 Roman 3, fxyz equal to x squared I plus y squared j plus z square. Okay, so the sigma is the surface of the region bounded by the cone z equal to z x squared plus y squared and plane z equal to 1. So we sketch the cone, and then we get like this. Okay, for the surface of the cone, we get we put the 1 into z, so into the equation cone. So we get the circle equation, which is x squared plus y squared equal to 1. So we sketch, we get like this. And then for the divergent f, we get 2 in bracket x plus y plus z bracket. So dv for this question is r dz dr d theta. So x equal to r cos theta, y equal to r sin theta. So r is substitute with 1. So we get cos theta for x and sin theta for y. So we write the function at the integral. So we get cos theta plus sin theta plus z in bracket r dz dr d theta. So limit for z we get from r until 1. So we get r is from the equation cone z equal to c r squared plus y squared. So x squared plus y squared equal to r squared. So c r squared, we get r. So z equal to r until 1. So for limit r radius, so 0 to 1, theta we get from the circle is 0 to 2 pi. 0 to 2 pi. Okay, so we integrate the function in terms of z. So we get zr cos theta plus zr sin theta plus z square over 2 r. So the limit is r1. So we will get r cos theta plus r sin theta plus r over 2 in bracket minus r square cos theta plus r square sin theta plus r cube over 2 in bracket and then we simplify, we get this r cos theta plus r sin theta plus r over 2 minus r squared cos theta minus r squared sin theta minus r cubed over 2 dr d theta. So we integrate in terms of r, so we get like this: r squared over 2 cos theta plus r squared over 2 sin theta plus r squared over 4 minus r cubed over 3 cos theta minus r cubed over 3 sin theta minus r to the power of 4 over 8. So we simplify, and then we get cos theta over 2 plus sin theta over 2 plus 1 over 4 minus cos over 3 minus sin over 3 minus 1 over 8. So we integrate in terms of theta, so we get sin theta over 6 minus cos theta over 6 plus theta over 8. So we will get the answer pi over 2.
For 3, 4, when it is given f x y z is equal to x cube I plus y cube j plus z cube k, and the surface of the cylinder is x squared plus y squared equal to 9 from z equal to 1 to z equal to 4. Firstly, we need to sketch the cylinder. In the cylinder, we can see there is blue surface on the above, so we need to look from the xy plane. In xy plane, we can see that the theta is rotating from 0 to 2 pi anti-clockwise, and the r is from 0 to 3. As we all know, the equation for f and ds is divergent f dv. For divergent f, we will get 3 multiplied with x squared plus y squared plus z squared. With the value of divergent f, z, theta and r, we put all of it into the equation. So the equation will be 3 multiply with x squared plus y squared plus z squared multiply with r dz with the limit 1 to 4, dr with the limit 0 to 3, and d theta with the limit 0 to 2 pi. For x squared and y squared, we need to change it into the r component. So x squared plus y squared is equal to r squared. So the equation will be r multiplied with r squared plus z squared dz with the limit 1 to 4, dr with the limit 0 to 3, and d theta with the limit 0 to 2 pi with 3 on the outside. So we integrate it one by one. So firstly, we integrate it with dz. With dz, we will get 3r cubed plus 21r dr with the limit 0 to 3, and d theta with the limit 0 to 2 pi with 3 on the outside. After that, we integrate it again with dr, follow with d theta. So the answer will be 931 1 over 2 pi. Thank you.